let's review for the performance final. So, question number 1 says the mean time spent in days waiting for a heart transplant, blood type A positive, in the state of Wisconsin is 128 days with a standard deviation of 24.5 days and is approximately normally distributed. So far we have 2 pieces of information, the mean number of days, and we've got our standard deviation. A says, what proportion of heart transplant patients have to wait longer than 178 days? Okay, in order to figure this problem out, you might have first tried to see if 178 was a full standard deviation away from our mean. But if you did that, you would have seen that it's not. So we're going to go into finding the z-score for this. So remember the z-score, it's z equals, it's a fraction. We start with the number that we want. So here we want 178 days. Subtract the mean, 128 days, and divide by the standard deviation. So if I plug that into my calculator, I'm going to do 178 minus 128 first, divided by 24.5, and I get a z-score of 2.04. And remember, we round to 2 decimal places because that's what our z-table shows. All right, so now I need to find the z-table for 2.04, and I actually have it below here. I'm going to go to the positive z-table because my z-score was positive, and I am looking for 2.04. So I'm going to start with the 2.0. I'm going down until I find 2.0. Here it is. And then I'm going to look for the 4, and it's going to be 0.04, right? That's this column right here. So I'm going to go over 0, 1, 2, 3, and 4. That is the probability. So 0.9793. So right now we have 0.9793. But I always say step 3 is to check your problem. Does this problem want to know the probability you have to wait less than or greater than the value we are looking at? And if you notice, this one says we want to wait longer than 178 days. The z-table will only ever tell us the probability less than. So anytime you want a probability greater than, you are going to have an extra step. So because this one is greater, we have this extra step where we have to do 1 minus the probability we found from the table. So 1 minus 0.9793. And we get that the probability is 0.0207. All right, in B it says, what proportion of and if you wanted to, this one would be, sorry guys, let's do this. This one as a percentage, you would move the decimal place over 2, and you'd get 2.07%. Just because I know the next one doesn't ask for a percent either, so just to remind you of how to write it as a percentage. All right, B, what proportion of heart transplant patients have to wait less than 95 days? All right, this time the value that we want is 95. So when I do my z-score, z equals the number I want, 95, minus the mean, 128, divided by the standard deviation. So I'm going to plug it in, starting with the numerator and dividing by that denominator. And I get a z-score of negative 1.35. So actually in my calculator, what it says is negative 1.346. So remember, we look 1 to the right of the place that we want to round, and because it's a 6, I rounded 4 up to 5. That'll make a big difference when you go to your z-table. So it's really important that you round correctly here, rounding to 2 decimal places. All right, so negative 1.35, I'm going to go down to my z table, the negative one, and I'm looking for negative 1.35. Starting with the just negative 1.3, I'm going to go down to negative 1.3. Here it is. And then I'm looking for 5. So I'm going to go over to that 0.05, and I can just count starting at 0. 0, 1, 2, 3, 4, and 5. There it is, 0.0885. All right, back up to here. So we've got 0.08, I forget, 85? Yep, 885. Awesome. Last thing to do is to check the problem. This problem wants the proportion that have to wait less than 95 days. So in this case, we are done because we were looking for the proportion less than. Again, as a percentage, this would be 8.85%. So what percent have to wait less than 95 days? 8.85%. All right, C. How many days would the top 35% of patients have to wait for a heart transplant? So if I'm going to sketch a little normal curve here, just to give us a good idea, the top 35% might be everybody here. That's the top 35%. I'm going to have to use my z-table to help me with this one. But remember, the z-table only ever tells us the less than probability. So in order to find the correct percentage here that I want to look at, right? Because if I look for 35% in the z-table, it's going to give me the lower 35%. So what I have to do is do 100 minus 35. If I want the top 35%, that means that there is 65% below. So the top 35%, there's 65% below. And that's what we're going to use in our z-table to help us find this. So we're going to 65% as a decimal would be 0.65. That's what we're going to look for inside of our z-table. We're going to get as close as we can. Let's scroll down to the z-tables again. I'm looking for 0.65. So you don't know if it's going to be the positive or the negative, but we are looking on the inside of the z-table. So all of these values here, looking for the closest to 0.65. And I notice this table, the highest it goes is 0.46. So let's go to the positive. We're looking for 0.65. All right, so I'm looking for the 0.6s. Here's some 0.65s, but what's the very closest? And between these two, the closest to 0.65 exactly would be the 0.6517. Because that's only 0.0017 away versus the other one's 0.002 away. So there's the closest. What we need to do now is to find what z-score would have given me this probability. So I see that it's got the 0.09. So 9 for the hundredths place. And then so we're working backwards. We have 0.3. So put that together, 0.39. That is our z-score. So let's go back up here. So it's the z-score that would get me a probability of 0.65 is 0.39. All right, well, now that I know the z-score, I'm going to use that to solve for how many days would have a z-score of 0.39. So using the equation we know for z-score, the value that we want is what we're trying to find, right? We don't know how many days. So we're going to do x minus the mean, 128, divided by the standard deviation of 24.5. All right, now I'm going to solve this. I'm going to start by multiplying both sides by the 24.5 because those will cancel. So times 24.5. And I get, there's not a lot of room here. 9.555 equals x minus 128. Next, I'm going to add 128 to both sides, and I get x equals 137.56 days. Now, if I was going to round this to a whole number of days, I would say that this is approximately 138 days. All right, question 2 says, a study showed that the number of hours a teenager sleeps during the school year is normally distributed with a mean of 7.6 and a standard deviation of 1.8 hours. So we've got our mean and standard deviation. Daniel sleeps only 6.8 hours a night. What percent of students sleep less hours than Daniel? All right, so we are going to start here by finding the z-score for Daniel. So Daniel sleeps 6.8 hours a night. So we're going to do z equals his amount, 6.8, minus the mean amount, 7.6, divided by the standard deviation, 1.8. So 6.8 minus 7.6 divided by 1.8, and we get negative 0.44. All right, step 1, find the z-score is done. Step 2 is to look at the table. So I'm going to the negative z-score table, and I can erase some of this. And we are looking for negative 0.44. So I'm going to start with the negative 0.4 first. So we're going down. There it is. And then we want the 4 in the hundredths place. So I'm going to go over 0, 1, 2, 3, 4. And so by using the table, I can find that the probability is 0.3300. All right, so now I've found the probability is 3300. You really don't need those zeros at the end, but we'll just write them because they were in the table. All right, step 3 is to check the problem, though. Does this problem want less than or greater than? And so when we reread it again, it says, what percent of students sleep less hours than Daniel? And so since our z table always tells us the probability less than, this is good. But there's one last thing. This one says what percent. So in this example, you have to give your answer in a percentage. So I'm going to move the decimal place over 2, and we get 33% as our answer. All right, question 3. A person was researching the strength of a particular glue between a metal and wood object. The researcher found that the mean weight held by 2 milliliters of glue was 1,250 grams, with a standard deviation of 60 grams. Assuming the test provided data that was normally distributed, answer the following. First thing we want to do is fill in a normal distribution curve. Our normal distribution curve always starts with the mean in the middle. So I'm going to do 1,250. And then to find all of the other points, we use the standard deviation. In order to move to the right, I'm just going to add the standard deviation. So I'm going to do 1,250 plus 60. So I get 1,310. Plus 60 again, I get 1,370. And one more time, I get 1,430. Now, to move to the left, I'm going to subtract the standard deviation. So I'm going to subtract 60 from the mean. I get 1,190. Repeat that again. Subtract 60. I get 1,130. And one last time, I get 1,070. All right, so now our normal distribution curve is filled in. We can move on to the next problem. It says, what is the probability the glue will hold 1,370 grams or more? First thing I want to do is find where is 1,370 grams. Oh, well, that value is right here. Okay, now we just want to total up the probabilities greater, or the percentages. Let's go back a little bit and actually fill in our percentages. I know that you've got a bunch of handouts and graphic organizers with these percentages, so hopefully you've got them down somewhere, but just in case you don't, here they are one more time. We're starting in the center with 34% on each side. The next one is 13.5%. Then we've got 2.35 and 0.15 on the ends. So these percentages are what percent of data would lie between these lines. And so now when I do this problem, I'm going to start by looking for 1370, which is right here. And then figure out if I want greater than 1370 or less than. And so this one says or more. Therefore, I want everything greater than this value. In order to find that, I just add up those two, 2.35 plus 0.15. And we get 2.5. Now, this is the percent. All of these are percents. But this question does not want our answer as a percentage. It wants our answer as a probability. So we have to almost work backwards and go from the percentage to a probability. When we do this, we move the decimal place left to. So 0.025 would be our probability here. All right, C says, what is the probability that the glue will hold less than 1,190 grams? All right, so we want to find 1,190. So here it is right here. And then this question asks for less than. So I need everything less than this value. All right, so we're going to add up all the percentages, 0.15 plus 2.35 plus 13.5. And when you add all those up, you get 16%. Now again, this wants a probability, so we've got to move the decimal place left to, and we actually have 0.16 probability. The last one says, what is the probability the glue will hold between 1,190 and 1,310? This time we want between, so we need to find both of these values. 1,190 is here. 1,310 is right here. And we want the probability in between. Again, you can just add these two. 34 plus 34 is 68%, which as a probability is 0.68.